Hello everyone and welcome to a fresh discussion which we are going to have in about groundwater recharge methods in India. And there are different methods depending on the subsurface geology or subsurface formations and even surface conditions also, like some areas may have more slopes, some area may have less slopes and that kind of thing. So, different methods about groundwater recharge were there in India, are there new methods are also coming. So, all those we will be discussing, and in future discussion we will be also discussing all kinds of recharge methods which are coming now or are being utilized in different parts of the country. So, we know that the main purpose of artificial recharge is to augment our groundwater regime, whatever the water is available as a surface flow during monsoon time or rainy season, and such kind of studies or schemes will following studies or knowledge is required. So, first what we require, the hydrometeorological studies or knowledge is required about a particular area, hydrological studies required, then what is the infiltration capacity of the soil, that kind of information or knowledge is required, then hydrogeological studies are required, and geophysical also knowledge is required. And so, one by one we will be going about these information or studies which are required before a groundwater recharge structure is adopted for a particular area. So, in hydrometeorological studies, what we need to know, the rainfall pattern and what are the losses through evaporation or evapotranspirations if it is having vegetation, and what are the climatological features of that particular area. Because as we know, in India we are having varied climate, having a cold deserts in Ladakh and having hot deserts in Rajasthan, in Jaisalmer and other areas. We are having very wettest place of the world in India, and we are also having very dry places in India. So, all kinds of climatic conditions we are having, and therefore, before a groundwater recharge method is adopted or a recharge structure is constructed at any location, any site, we need to have lot of information related with meteorology. So, hydrometeorology, that means mainly we are focusing on meteorological data which is directly having bearings on hydrology, and also to bring out the extent of evaporation losses if it is a open water body or directly from surface if it is not covered with vegetation, and especially in post monsoon periods which would be helpful in designing the storage of particular capacity with a view to have minimum evaporation losses. So, while designing these groundwater recharge structures, if that kind of information is there, then because after all we will be creating a large surface of water, and if there are water losses through evaporation process, then that may be a concern for us. Like for example, in semi-arid regions of India, evaporation losses are quite significant. So, especially after the January and when the temperatures start rising. So, whether that stored water, before that the stored water should percolate or recharge the groundwater regime, and therefore, once we enter in the towards hot summer, surface water is little left, only the water has gone for the groundwater reservoir. So, this kind of management, this kind of things can also be estimated, understood before a site is chosen for groundwater recharge structure, and the size of that structure also, not only the configuration, not only the type, but size, so that water surface where the losses are there we can minimize, particularly in warm months or hot months. Similarly, on the rainfall intensity, number of rainy days, etc., of course will help to deciding the capacity and design of these structures, groundwater artificial recharge structures for groundwater augmentation. Second studies which are required for a particular area is hydrologic studies. So, there are four types of sources of water on surface condition, that is the in situ precipitation on the water side. Generally such studies, this is important point here, that studies should be done based on water set. So that whatever the estimations or things are being done will be more accurate. If we follow the political boundaries, then our estimates or these studies may go wild, because the rain does not know the political boundaries, but rain the water set boundaries will have control over this. So, which is coming through the topography or ridges and other things. So, in situ precipitation on a particular water set or the water set which is under study, or surface water bodies like surface canals which are supplying water from large reservoir within the basin or within a water set, surface supplies through trans basin water transfer. And there are this is indirectly what we are saying here is the interlinking of rivers. At local level, some places this kind of trans basin water transfers have been done. A project which is about to be completed is that about in central India, that Betwa Son water transfer or that kind of interlinking projects are there. So, that kind of knowledge is also required, that how much water will come across a water set or a nearby water set or basin. Secondly, also one should know about treated municipal and industrial waters, wastewater. So, how much that water, and it has to be treated, otherwise it is going to be a problem in case of groundwater recharge. So, if it is not treated, it is going to harm our groundwater aquifers. So, that kind of information. Further, in hydrological conditions or studies, we need to have one or more or other two sources may be available in any of the situations, and which will require the following information. What are that? The quantity that may be diverted by artificial recharge. So, how much water, if a small stream is there, how much water can be diverted? Entire water you cannot divert, because in the downstream many people might be using. One has to should be concerned about aquatic life in any river systems also or any water body system. So, that concern or that should be also be addressed. Now, time has to be also there, which time the water source water will be available, and just after the monsoon or during the monsoon only, and so on and so forth. And the quality of source water, and that pre-treatment required, if at all it is required, that is also has to be before it is entered through groundwater recharge structure into groundwater regime. So, this pre-treatment is very much required, if at all, and the water, if water quality of the source water which is going to be put as for groundwater recharge structure, if it is good, fine, if it is not, then treatment might be required. And a convenience system required to bring the water to the recharge site, because you cannot directly block a stream for recharge in many cases. So, what is the canal system or whatever the channel system is there, that is also required. So, in under this hydrological studies which are undertaken to work out surplus monsoon runoff, which can be harnessed as source water for artificial recharge. And this surplus monsoon water is really runoff water is really used in many areas, and especially I am talking about hard rock terrain, where water scarcity is another problem. So, by having so much surplus monsoon runoff water, if we can by some means can use this water for recharge, that would be very nice. Another study which involves for groundwater recharge structures is that soil infiltration study, site specific soil infiltration. So, if we are thinking of creating a reservoir, that is called also water spreading method of artificial recharge, soil and land use control the rate of infiltration. So, the area which will be flooded with water, what is the soil conditions? If it is clay soil, then it is not going to infiltrate water significantly. If it is sandy soil, of course, it is going to infiltrate lot of water. So, that means the information about the soil information about the land. Land here also means the slopes, land also means here the geology. But specific to geology, that discussion will also come little later. And so, control the rate of infiltration and downward percolation of the water applied to the surface. So, what kind of land use is there? Forest land is there, agricultural land there, what kind of soil are there? All these information are required, because they are going to influence our soil infiltration and ultimately they are going to influence our results related with groundwater recharge. So, infiltration of water through the surface takes place generally over a small period of time, only when rainfall occurs, and initially that might be high, but later on it reduces quite significantly. So, it is the process of redistribution of soil water that goes for most of the time, goes on the most of the time as a surface runoff. So, for infiltration studies, a very standard technique is there, that is double ring infiltrometer is there. So, in order to know the soil infiltration rate, tests are carried out using similar kind of instruments, which is called cylinder or flood infiltrometer, which are common type of instruments which measure the infiltration as the rate of water leaving the device. So, we put the water, we keep measuring the water with the time, and we know that how much water has gone inside. So, that is what infiltrometer is there. And this infiltrometer rates our soil can be prepared, because if there are, say, in a watershed, if there are 4 types of soils, then over each soil such a test should be done, so that you know what is the average infiltration rate in that watershed. And all this information about soil infiltration will help to design the suitable artificial recharge structure, and also will assess the extent of recharge from these structures. What would be spatial extent and also vertical extent there. Now, in the D, that is the fourth is the hydrogeological studies, and this we have discussed in extensively while discussing geological methods of groundwater exploration. And there, that means we need a geological map, regional geological map, local geological map, and what are the formations, strata are there, and what are their ages, what are the their if weathering information is there, how deep that weathering is, what are the structures, especially the fractures, faults, and what kind of dip is there, what kind of structure, also the folds and other things, and if there are some intrusive bodies, etc. So, all kinds of information are required. The example here is shown of geological map of Uttarakhand. So, lot of if you see the lithology, geology is varying very significantly, even a small, but except in the lower part, which is representing the Indo-Gangetic plain. So, there are only 2 types of units, but rest are having varied geology, and therefore, for each site the detailed geological study is required, where a groundwater recharge structure will be installed. Further, in hydrogeological studies, or these maps are prepared, which will bring the correlation of topography and drainage to the geological context, because slopes will also play a very important role, and whatever the drainage systems they are. For this we can also employ satellite images, which are very useful to identify different geomorphic units and lineaments, a linear feature which will govern the occurrence and movement of our groundwater, so that much information can be extracted. Further, detailed hydrogeological study is required or imperative to know precisely the promising hydrogeological units for recharge and correctly decide on the location and type of structures to be constructed. So, this is the essential requirements, because everywhere you do not have the soil cover. So, you may be having just simple rocks. So, what are the rocks are there, what are their characteristics. So, hydrogeological studies will become very useful. Now, there are different sections in this. So, first one is required a detailed hydrologic mapping. I have just mentioned that for that particular area One, you require a regional one, then you require a local one. So, regional maps, geological maps might be available from like organizations like Geological Survey of India, but of a large scale for a small basin you have to do the mapping or do the refinements of the already maps which are available and convert to a large scale detailed maps. So, for this we need various types of maps, maps showing hydrogeological units which are demarcated on the basis of water bearing capabilities both for shallow and deeper aquifers or deeper levels. Also maps showing groundwater contours to determine the form of water table. If we are having that kind of information, that can also be obtained in the field or through some organizations, because each state in India having their own groundwater department and they should have been collecting the data pre-monsoon, post-monsoon for many areas of their state. So, that data can also be collected and such contour maps can be prepared. Further, we also require the depth to the water table which are usually compiled for the period of maximum, minimum and mean annual position of water table. These organization, groundwater organization can also provide such maps which are the maximum, minimum and mean, and what time we are having the shallowest water table, what time are having deepest and what is the an average of this. And the maps are also required to show amplitudes of groundwater level fluctuation, and that can be estimated using pre-monsoon and post-monsoon data, and maximum position of water table of considerable importance for artificial recharge studies. So, that is also required, whether the water table is becoming very shallow during the monsoon time. If it is there, then we have to find out the areas where that doesn't too shallow, means not too close to the surface. Then during monsoon there will not be any recharge, because water table itself is coming above or near the surface. So, that kind of information is also required. A map will require which will be showing piezometric head in deeper aquifers and their variations with time, if at all these informations are available. Sometimes such detailed information might not be available. Further, we require groundwater potential of different hydrogeological units which are present in that basin or area, and level of groundwater development, how much development or how much exploitation of groundwater is taking place in a particular basin or in watershed or an area. Further, if it is possible to have that information, that will also helpful chemical quality of groundwater for different, if there are different aquifers and that kind of information is available, fantastic. So, these sometimes you may not get all these information. So, whatever the informations are available, accordingly the judgment has to be made for installing a groundwater recharge structure. So, at this level of hydrogeological mapping of the area, many questions can be answered or should be responded. The first one, whether there is any gap in the data of subsurface geology of the available lithological logs or boreholes in the area are sufficient to arrive a correct picture of aquifer geometry of the area. That means we are asking lot of details about an aquifer, and also whether the available data and aquifer parameters is sufficient in case of area shows promise for artificial recharge techniques for deeper aquifers through injection wells, and also can be available groundwater structure serve the purpose of monitoring the effects of artificial recharge project. Because after all, if a project has come or artificial recharge structure has come, we want to see the performance. So, would it be possible to monitor the performance of such things, and for which we also require maybe geophysical studies, and the main purpose of analyzing these methods for selection of appropriate site for artificial recharge studies, and that will assess the unknown subsurface hydrogeological conditions. So, all these studies are required in case of large groundwater recharge structures. But if it is a local groundwater structures, which we will be discussing in subsequent discussions, then probably we will not be requiring too much such studies. Simple ground level studies and a study about the surroundings can help us to decide where that groundwater structure should come. But anyway, for large and for efficient groundwater recharge structures, if whatever the knowledge if can be gained even through the geophysical studies should be there, which will bring the comparative picture of the subsurface litho environments, litho units, surface manifestation of such structures and correlate them with the hydrogeologic settings which we have just discussed. Further defining the subsurface structures and lithology, it can also identify the brackish or freshwater groundwater interface. So, geophysical studies are capable of identifying this. That can also help, and this is important in case of somebody is going to have a recharge structure and near near sea areas or other things, or where the contaminated zones are there, saline water are nearby, then that thing is also very much required. Now, chemical quality of source water, if that can be assessed before that thing, wonderful. And we have already discussed that if water quality is not good, which will be used for groundwater recharge, then treatment is required. So, treatment before being used in recharge installation, that must be there. The poor quality water, surface water should not enter in groundwater aquifers, because they will really harm our aquifers, and for very long time these cannot be flushed out either. So, all efforts should be made to establish that whatever the water which is going inside through groundwater recharge structures is having good quality in terms of chemical quality. It is also related to changes in soil structure and biological phenomena which take place when infiltration begins, to changes brought to the environmental conditions. So, initial conditions in infiltration may be different than later conditions in infiltration. So, what are the changes? If those can be estimated, wonderful. Chemical and bacteriological analysis of source water, beside that groundwater is therefore essential, because these things are will become important if not a fresh water or good quality water is being used as source water. Now, suspended matter and TDS and other things may clog the soil in two different ways. So, if water is having too much silt or too much to dissolved solids, and they will precipitate around soil or the sediments which are there, and they will block the flow or infiltration, they will reduce the infiltration. So, therefore, that kind of knowledge is also very much required. So, major requirement for waters that are to be used in recharge projects is that they are silt free, and some in monsoon time that is a problem. The water is not as clean as one would like to have. So, if without desilting, if the same water is allowed to enter in groundwater regime, your groundwater structure will not be efficient at all, because of silt the top surface will block further infiltration of the water. So, it has to be first desilted and then it should be allowed to enter in groundwater regime through infiltration and percolation. As we know, the silt is a very fine sediments which are undissolved solid matter, usually measured in milligram per liter, and if we want to see in terms of size, then it is a different criteria. But here we are seeing that in a water how many milligrams per liter. So, this will settle in a stagnant water. If water in this siltal tank, this is what it is done, that water is left for some time, stand still, and then the silt will settle, and if there is a velocities which do not exceed 0.1 meter per hour, then silt will settle. So, in that way this can be done. For all these things are required initially or usually for large groundwater recharge structures. So, these if silt is allowed, then it will go and it will block our filled up with our interstices of these soils, and whatever the sediments are there, even the hard rocks which are having only little space which will allow water to move. So, all these will create problem there, and so that has to be avoided. Now, what are the methods? One method I have already mentioned, that desilting. So, what are the methods by which we can remove or reduce the clogging effect because of this silt or suspended matters? Periodical removing of the mud cake and dicing or scraping of the surface layer. Sometimes it is impractical to do like this. So, it is better to first desilt it and then allow the water. Installation of a filter on the surface and a permeability of which is lower than that of natural strata. So, if permeability lower, then you can get the silt settled there, it becomes a filter, and that will not allow silt to go inside. Additional some organic matter or chemicals can also be used, but again this is a last resort, should not be used, because directly one day they harm our groundwater quality. Further, cultivation of certain plant covers, biological solutions, notably certain kind of grass, can reduce the silt entering or clogging effect, and that may be utilized. There will not be any harm to that, our groundwater quality. Further, providing inverted filter consisting of fine sand, coarse sand and gravel at the bottom for infiltration pits. This is a very common practice which is done, inverted. So, on the top you are having fine sand, that will block your initial whatever the silt is there. Then you are having coarse sand and gravel at the bottom. So, this is a reverse sequence, reverse sediments will help to block the clogging and block the suspended particles. Clogging by biological activities will depend on mineralogical and organic composition of water and basin floor and upon the grain size and permeability of the floor. Also, the feasibility method of these treatment developed for consist in thoroughly drying the ground under the basin. So, now we are coming to the end of this discussion about groundwater recharge methods in India, and there are of course various. We have already discussed what are the requirement, what are the studies are there. So, then finally we come to the assessment of subsurface potential for groundwater recharge, and we have to assess before we enter in this or before a site is decided for groundwater recharge structure. So, based on several studies which we have discussed, like hydrogeological, hydrometeorological, geophysical studies, the thickness of potential unsaturated zone for recharge may be worked out, and that will allow us to assess the potential for artificial recharge in terms of volume of water which can be accommodated in this zone with source water availability. Because for any site you propose a groundwater recharge structure, the decision makers will ask how much recharge it is going to happen to our groundwater regime, and of course, what is the cost is going to be. So, cost analysis is a different thing, but we can give some idea that this volume of water is going to inside our groundwater aquifers, and otherwise this water is going to flow as a surface runoff and going to waste out from this basin or watershed. So, if sufficient amount of knowledge has already been obtained for a particular area, watershed and site, then we can tell to decision maker that this volume of water I am going to store as subsurface, otherwise it was not being done without these structures. So, studies should also bring out the potential of unsaturated zones in terms of total volume in which can be recharged. This is what the decision makers want. Before they approve your project, groundwater recharge structure, location, everything you have to assess. When it comes to immediately the question is, many questions which we have also discussed earlier very briefly when we started discussing about water exploration and recharge, that they will ask that how much water will get augmented to our aquifers, how much time it will take. That is another important question they will ask. Okay, today we are going to construct a recharge structure. So, whether 1 monsoon, 2 monsoon, 3 monsoon, after that we will get a shallow groundwater condition or not. So, then only you can answer once you are having complete knowledge of that area before you go for a groundwater recharge structure and approvals from the authority. So, with this I end this discussion. Thank you very much.